All right, let's take a look at these word problems from last class. So we have Bilbo became the first hobbit to orbit the planet when one of Gandalf's spells went horribly wrong. Oh my gosh. Bilbo's distance from the equator varied sinusoidally with time. After 45 minutes, Bilbo was at Aphelion, the farthest planet. Great. A distance of 3,200 miles. So I'm going to start there. And in drawing my graph, I'm going to have at 45 minutes, we are at the furthest planet, 3,200 miles away. Point. Half a cycle later, he was at this other planet, which was the closest, 1,600. Okay? He completes one orbit every 80 minutes. So from max to max takes him 80 minutes. So if I want to figure out this next point, I'm going to add 80 to 45 and get 125. Let's see, is that all we need? Great. Okay, in order to start writing our equation, we need to figure out A, B, C, and D. That's our next step, is write the equation. A is the amplitude. First, I'm going to figure out this middle line. So I need to figure out what's halfway between 3,200 and 1,600. You could add these and divide by 2 to find the average. And that would be 2,400. So how far up and down does it go each time? 800. B is the period. So the formula for period, remember, is 2 pi over B. Well, our period took 80 minutes. So if I'm solving for B, that'll end up being 2 pi over 80, which simplifies to pi over 40. C is the phase shift. Our starting point is 45, so I'll say we went to the right 45. D is the vertical slide where our sinusoidal axis is, and that's up 2,400. Okay, so if I'm going to write my equation in terms of T, so I'll start with y equals the amplitude. This is a positive cosine because it's max to max. So 800 cosine. B is pi over 40. In terms of t, so my variable is t to the right 45, so minus 45, and then up 2,400, so plus 2,400. Now what we're going to go ahead and do is go into Desmos and type in the equation. So as you can see, I've typed my equation into Desmos, and then I had to scroll out a lot to get to a minimum and a maximum of 1,600 and 3,200. Just keep scrolling if you can't find it. And now we're going to answer these questions. So first, we're going to predict the distances he is from the planet at 64 minutes and 230 minutes. In order to do that, we're going to look at our table because our time is our x-axis. We can just put in the x values to find those y values, the distances. We did find yesterday that if you did not have this little settings button, if you refresh your screen, sometimes it pops back up. But if not, I did find another calculator, so get with me if you need help there. So I click this to go to my table. And the first distance for the time that I get, it gives me 64 minutes. So here we are at 64 minutes, and our distance is 2,462.77 miles. So that's what I'm writing on my paper at 64 minutes. 2,462.77 miles. Next one I need is 230. So I'm going to go to my table, type in 230. Here we are. And there's our distance, 2,093.85 miles. The next piece asks us to find the first time when his distance is 2,800 miles from the planet. So what I want to do now is figure out where is 800. I'm going to do y equals 2,800, and that'll give me this line here. I'm going to zoom in. Here's my y-axis. So the first time he hit 2,800 miles is right here. We need to figure out this coordinate. So on this, I'll just click it. And for me, it says 31. If I zoom in more, let's confirm. Now it's 31.4, 31.6. I'm going to keep zooming in to get a more accurate reading. I'm going to say probably 31.6 is probably maybe 31.7. I'm going to keep zooming in. Again, this is a terrible graph to do this on. You got a calculator, you get an exact number. For me, I'm going to leave it on 31.66. So his distance is at 2,800 miles, took 31.66, what is it, minutes. Again, this is an approximation. So on any further test, I will play approximately around all the things. So if I'm going to look back at my paper, here are the numbers that I got from the table, and here was the x value at 2,800 miles. And that's how we did sinusoidal functions.